Okay, so this is the last lesson on chapter 10, Pulleys part 2. And what we're going to be looking at today is a pulley along a horizontal table. Okay, so last lesson we were looking at pulleys where they were both vertically hanging down, and today it's one weight is on the table. We've got a smooth pulley here attached at the end of the table, smooth, so there's no friction here, and another pulley, another weight at the end of the pulley going down, so that will have gravitational force, so this will have weight. This one is on a rough table, okay, so there's going to be a frictional force going back this way. We're told in the question, and this is a question on slide 103, let's write that down, this is slide 103 in the attached PowerPoint. So if you want to read the question from there in full, it's on there. So you've got a rough table, and it tells you in the question that the friction, the resistance to motion, is 3.2 newtons. Okay, so this table, this rough table, has a pulling force this way, resistance to motion of 3.2 newtons. And important, the whole system is released from rest. So this will be held, and then this is all at rest at the beginning. Right, we've got 4 parts to this question, and here is the first part. It asks you to write an equation of motion for particle P. So for particle P, if we look at this here, and let me just put in, we've got the tension here, and tension here, and tension here, and an equal and opposite tension here, and the weight 4G. So before you answer the questions, it's important to put in all your forces for the system. Right, write an equation of motion for P. Right, well, if I'm just going to actually just look at this section of P here. If I just draw this out again, I mean, you don't need to do this, but this is just for my teaching purposes. So if you've got 3.2 newtons this way, and you've got T that way. Okay, so we know that this weight is heavier than this weight, so the whole system is going to move going this way. Okay, so the acceleration, so this is going to move down, so we'll have an acceleration here. This is going to move this way, an acceleration here. So this particle is moving along this way. Now, because this is a light, inextensible string, the acceleration is the same for the whole system. So this is accelerating at the same as this. Right, so let's write down our equation of motion. We know that's F equals ma. So we're going to resolve horizontally at P. We've got T, which is positive, one of my forces, minus the friction, which is negative because it's going the opposite way to the direction of motion, equals my mass, 2 kilograms, times my acceleration, which I don't know. So here is my answer for part A. Right, next it says write the equation of motion for Q. So if we look at Q, if I just move this up a bit now, if we look at Q, if I just draw my diagram, here's Q. We've got 4 kilograms, we've got our tension going upwards, we've got our weight, so 4G going downwards, and we're going to resolve in a vertical motion in the direction of motion. So we've got F equals ma, we're going to resolve at Q going downwards. So we've got 4G, the weight going downwards, minus the tension, equals the mass times the acceleration. So here's my equation of motion for B. Right, C asks us find the acceleration of P and Q. So they've both got the same acceleration. I've now got my two equations which I can solve simultaneously. So if I just write those down again, if I just write this underneath here, I'm going to write to minus t plus 4g equals 4a. So I'll put the two equations of motion underneath each other. I'm going to add these, so t add minus t will be no t. Add these, I'll get oh yeah, so 4g is, if I do 4 times 9.8, okay, that's 39.2. So I could write here 39.2 instead. And if I subtract those two, I'll get 36. Add these two, I'll get 6a. So I've added these two to get 36, add these two, get 6a. So the acceleration is 6 meters per second squared. And that's the whole system is moving with the same acceleration. Right, now that's using my equations of motion. Part D, the last part, okay, it says particle Q is 2 meters above the ground when released from rest. Find the time taken for particle Q to reach the ground. So you've got this particle Q here, and it's 2 meters above the ground. So here's the ground. Okay, so we're going to use now SUVAT for this question, and we're asked to find the time. Now we know the acceleration is 6 meters per second squared. We know it's released from rest. Okay, we know the distance is 2 meters. The final velocity when it hits the ground we don't know, but we don't need to use that for this question. So we think about which of the kinematic equations we're going to use, and we're going to use this one. And if we bung all of this into here, then we would work out T to be this answer. Okay, so that's a typical pulley question where it's horizontal. So I'm going to give you one to do now. They do get a lot harder than this. So this is just the start. So I want you to make sure you can do the beginning of these questions. So this is the one I would like you to try. Okay, so very similar. If you forget how to do it, then go back to the video, rewind and have another look. So you've got this system here. You've got 5 kilograms and 4 kilograms. And it's on a smooth table, so there's no frictional force here. It's released from rest with the string taut, a light inextensible string, so the acceleration and tension is the same throughout. And you're told that B is 1.4 meters above the ground. Okay, so if I was to show that on here, here would be my ground, and this distance here is 1.4 meters. Okay, so you're going to do A and B. I will just stick in the forces of motion first. Okay, you've got tension going up, you've got 4G going down. Now, to do part A, you're going to need to do equation of motion at here, equation of motion here. Have two simultaneous equations and you can find A. Then use SUVAT to find the time it takes to go down this 1.4 meters. Okay, so pause the video, have a go, and I'll go through the answers. Right, well done. Let's see how you got on with that. So I'm going to resolve, so for part A, I think I'll get another piece of paper here. So for part A, I'm going to resolve horizontally, F equals ma at my 5 kilogram weight. So I've got tension going this way. I've got no resistance to motion, okay? So F equals ma, and I know that it's going this way. So I've got T is my only force equals the mass times my acceleration. So I've resolved horizontally at A. Right, if I now resolve vertically at B in the direction of motion to get my equation of motion here. So I've got 4g going downwards, I've got minus t going upwards equals mass times acceleration. So I've got my two equations which I now need to solve simultaneously. So I'm going to write this other equation underneath. So I've got t equals 5a. I'm going to add these two equations. So I've got 4g equals 9a. So that's 4 times 9.8 equals 9a. Now I'm sitting here without my calculator. So I'm just going to grab my calculator. Give me a second. Right, okay. I have my calculator. So A will be 4 times 9.8 divided by 9, which equals 4.36 to 2 decimal places. Okay, and then for part B, it asks you to find the time taken for B to hit the ground. So this is a SUVAT question. So what do I know? I know my distance. I know it's initially 0 velocity. I don't know my final velocity. I worked out my acceleration from before, and I'm asked to find the time taken. So I just bung all of that into my equation of motion, and I work out t. Okay, I'm going to pause the video while I do work that out for you. Okay, so we're going to put all of that into this equation of motion here, and we put it in, sub it all in, and we get t to be 0.8 seconds. So not very long time to hit the ground. Right, so I'm hoping you have got the basics of horizontal pulleys. If not, please go back and try this again, and please email me at any point that you don't understand before you carry on here. Right, next, we are now going to look at a harder example, which is on page 174 of your book. Example 14, so I want you to have a read of this, and we're going to have a go at these three questions. A and B, very similar to what we've just done. C is the difficult bit. So you can have a go at A and B first, pause the video, think about C before I go through it, and then I'll go through it with you. Okay, so pause, have a go at A and B. Right, so you've read this in the book on page 174, and the first question is you want to find the acceleration of the system. So before we can do this, we need to put in our forces. So we've got friction to motion this way of 0.08 G. We've got tension going up, tension going down, and our weight 0.8 G. The whole thing is accelerating this way, the whole system. We can treat the whole system as 1. Right, so we're going to do F equals ma. So we're going to resolve at A horizontally. F equals ma. So I've got my tension minus my friction. That's 9.8. G is 9.8 equals my mass times my acceleration. I'm going to resolve at B going vertically down. So I've got my weight in the positive direction minus my tension equals my mass times acceleration. So I've got my two equations of motion. So I'm going to solve those simultaneously to get the acceleration, which is 0.6 g. Okay, to be exact, and this is the example in the book. So just solving those simultaneously. Okay, the time taken, part B, to reach the ground. Okay, so B is 0.5 meters above the ground. The distance is 0.5 meters here, if I just extend this. Okay. So we're going to use SUVAT, exactly the same as the last two examples. You're going to do S, U, V, A, T. You want to work out time. You know acceleration. You don't know final velocity. It starts off at rest and the distance travelled is 0.5. You're going to bung all of that into S equals UT plus a half AT squared, and you will get T to be 0.41 seconds to two significant figures. Right, nothing different to the first two examples. Right, here comes the tricky bits. Okay, so this is your grade A of the question. You want to find the total distance travelled by A before it comes to rest. Okay, so let's think about what is happening to the whole of this system here. So what is happening is as B is falling down 0.5 meters, A is travelling 0.5 meters. Okay, so this will travel 0.5 and this will travel 0.5. Okay, so that's the first bit. Now B hits the ground. Now what happens when B hits the ground? Well, the string will become slack, okay, but because A has got speed, then it will carry on moving, but the friction to motion will slow it down. Okay, so it's going to decelerate and stop. Now we know that it's we're told right back at the beginning that the distance of A to the pulley is 4.5 meters, and that's really important because if A was to travel more than 4.5 meters, it's going to hit the pulley, and we don't want that to happen. So normally, in all the questions I've seen, it never hits this pulley because then mechanics gets incredibly difficult. Right, so B is going to hit the floor, A is going to travel 0.5 meters, the string becomes slack, A is going to continue moving because it's got speed, but it's going to decelerate because the friction of the table is going to pull it back. Right, so let's find if we can find the deceleration of A once the string becomes slack, then we can use SUVAT on A to find out how far it goes. Yeah, got me? So let's look at what we've got here. Now, the tension will no longer be in this string, yeah, because it's slack. So all we have is we have the friction, the resistance to motion, because the table is still rough. Okay, this is our particle A, and that had a mass of 0.4 kilograms. So let's use F equals ma. Let's resolve at A in a horizontal direction. So the only force I now have, because I've got no tension, because this string, this has reached the floor here now. Okay, B is now on the floor, the string has become slack. So I've got negative 0.08 g equals my mass times my acceleration of this particle. And if I work out A now using G to be 9.8, in fact I'm going to keep G there, I will have A as a negative 0.2 G. It's negative because A is decelerating, it's slowing down due to the friction of the table. So I've got my acceleration, and now I need to work out the distance that it moves. So I'm going to use SUVAT, S-U-V-A-T. So I want to find how far it travels. What is well, I know the final velocity is going to be 0 when it's stopped. I know the acceleration is going to be negative 0.2 g. Now, I don't know how long it takes, so I can't use time. So I need to know what my initial velocity of A is. So how do I find my initial velocity of A? Well, that would be the same as the velocity of B when it hits the ground. So when B hits the ground here, this velocity will be the same as the initial velocity of A after A has travelled 0.5 metres. Okay, so before I can look at this bit, I need to use SUVAT on A at the beginning. So on B. So I'm looking at B now as it's travelling down. Well, I know B travels 0.5 metres. I know it starts at rest. I'm going to find the final velocity when it hits the ground. I know the acceleration from part A is 0.6 g. And the time, well, I'm not going to use that, okay? I'm not going to use that. So, which equation of motion should I use for this? I'm going to use this one, the one without time. I'm going to bung everything into here, and I'm going to get V to be 2.42 meters per second. Right, so that is the final velocity when B hits the floor, which is the same as the initial velocity of A as it begins its second part of its travelling. So if we put this in here, 2.42. So let's go back to this now. So let's look at my SUVAT. I've got all my bits and pieces. I want to find S. I've got no T involved here. So I'm going to use this equation of motion again. I'm going to bung everything into here to find S, and that comes out to be 1.5 meters. So I'm putting all of this into here. So A has travelled 0.5 meters when B travelled 0.5 meters. The string becomes slack. It then travels another 1.5 meters. So the total distance that A has travelled, the total distance will be 0.5 meters plus 1.5 meters, i.e. 2 meters. So that's lucky. It doesn't reach the pulley because the distance from A to the pulley is 4.5 meters. Right, I really want you to go through that again. If there was any problems, try and do it on your own. It is in the book, okay? It is on my PowerPoint, and it is now in the video. A really important example. Right, it's your turn. I will put some more videos that you can watch from TL Maths, the Love Heart guy. If you're struggling with questions 4 and 5 from exercise 10F, and I'll put that on Show My Homework for when that is due for. Okay, and now I've finished teaching chapter 10. I'm going to give you some questions from the mixed exercise after you've done this, and then you'll be doing a test on chapter 10. Okay, take care.